everyone. In this video we will discuss about the molarity and we will solve all kind of problems that is asked in IIT and NEET based on the molarity. It is to be noted that molarity is number of solute in number of moles of solute present in 1 liter of solution. So it should be remember the definition, the moles of solute present in 1 liter of solution. Now we will apply this in 1 to 9 example. So the first case is given as 3.011 into 10 to the power 23 molecules of urea present in 200 ml of solution. So sometime student try to find out the formula of urea, but it is to be noted that there is no need to the formula of urea. We can directly calculate, as the definition states that number of moles. So moles of urea from the molecules will be 3.011 into 10 to the power 23 divided by 6.022 into 10 to the power 23. This is the moles of urea, and this should be present in 1000 ml of solution. So on solving this, definitely you will get 2.5 m, right? In the next question, it is given that 10% W by W NaOH solution. So in the last lecture we discussed about how we can decode these concentration term. So 10% W by NaOH means 10 gram of NaOH present in 100 gram of solution. So obviously molarity is moles of solute, which is 10 by 40 moles of NaOH, which will be present in, because the 40 gram is the mass of solution, we will divide this by 1.2. so the mass by density is volume, so 40 upon 1.2 is volume into 1000. So definitely this will be 250. So 250 upon 40 into 1.2. On solving this, you will get the molarity of this solution. In the next term, in the case third, 10% W by V NaOH solution of density 1 gram per ml is given. So we will decode this concentration term. 10 gram of NaOH will be present in 100 ml of solution. So molarity can be easily calculated. The moles of NaOH will be 10 by 40 present in 100 ml of solution, which will be 100 into 1000. So definitely the molarity will be equal to 2.5 m. This is the third part. In the next part, which is very important part, 2m NaOH solution is given. In all cases we are relating the capital M. In the first case we have related with the number of molecules, in the second case with the number percentage by mass, and in the third case with percentage W by V. And the fourth case, which is very important with respect to all examination, in which the 2m NaOH solution is given. Again, the molarity. How we can calculate the molarity? First we should decode what is mean by 2m NaOH solution, which means that 2 moles of NaOH, 2 moles of NaOH, which is 80 gram of NaOH, that will be present in 1000 gram of solvent. It is to be noted that it is the mass of solvent. So the molarity will be equal to 2 moles of NaOH divided by volume of solution is required. So the density of solution is given. So first we will calculate the mass of solution. That will be equal to 80 gram, which is the mass of solute, which is NaOH, and the mass of solvent is 1000 gram. This will be 1000 gram. So this is the mass of solution divided by density, which is 1.2. This will represent the volume of solution in 2000. So what is the final equation? It will be 2000 divided by 1080 into 1.2. Simply we can solving this and we can find the molarity of this solution when the molality of solution is given. In the case 5, 720 gram of H2O, density 1 gram per ml is given. So definitely 720 gram of H2O is given. So simply the moles of water will be 720 upon 18, and the 720 gram of H2O is given and the density of water is 1 gram per ml. So the volume of water will be 720 ml into 1000. So definitely this is again moles. 720 on 720 it is cancelled, and 1000 by 18 this will give 55.56. So students are advised to learn the value of 1000 by 18, which is 55.56, because sometime it helps to make the calculation easier. And the next part, aqueous solution of 200 ppm CaCO3. It means that this relation gives the relation between the parts per million and molarity. So how we can relate this? 200 ppm, simply ppm means milligram per liter. So here is given that 200 ppm of CaCO3, which means that simply 200 milligram per liter of CaCO3. So how we can find the molarity? So if we wish to calculate the molarity, 200 into 10 to the power minus 3, which is gram of calcium carbonate, and divided by 100, this will be the moles of calcium carbonate into volume of solution is 1 liter, right? So how we can solve this? We can solve this and we will get the molarity is 2 into 10 to the power minus 3 capital M. So this is the relation between the molarity and ppm. In the next part, aqueous solution of urea with mole fraction 0.2 is given. It is to be noted that aqueous solution of urea is given. So mole fraction of solvent will be 0.8, because the mole fraction of solute is 0.2. So the mole fraction of solvent will be 0.8. So directly we can use the relation that capital M equal to 1000 into D into chi1 divided by M1 chi1 plus M2 chi2, where chi1 is the mole fraction of solute, chi2 is the mole fraction of solvent, and M1 stands for the molecular mass of solute and M2 stands for the molecular mass of solvent. So we can put the value of mole fraction of solute is 0.1 and mole fraction of solvent is 0.2. On solving this, we can get the answer. Again, in this formula, if we will divide the equation by D1, I want to say that if this D is shifted to into denominator, then you will get the volume of solution. In the next problem, liquid HCl is given. The density of this HCl is 1.17 gram per cc. So to calculate the molarity, how we can decode this? Density is given as 1.17 gram per cc. It means that 1 ml contains 1.17 gram. We can simplify this. 1 ml contains 1.17 gram of HCl. Yeah, we can say simply 1.17 divided by 36.5 moles of HCl. So this is present in 1 ml. These moles are present in 1 ml. So for 1000 ml, which is 1 liter, we can easily calculate as 1.17 divided by 36.5 into 1000. So this will be the molarity of this solution, because the number of moles which is present in 1 liter of solution is the molarity of that solution. In the last question, it is given that 40 gram of MgO is dissolved in 200 gram of H2O to make solution density of 1.2 gram ml per ml. This is very important question, and it is to be noted that 40 gram of MgO is dissolved in 200 gram of H2O. So students are advised to go through the question carefully, because it is the mass of H2O is given, right? It is not the mass of solution. So first we will find molarity as 40 by 40, which is the moles of solute, which is mg. And now volume of solution is to be calculated. So how we can calculate the volume of solution? So 200 gram plus 40, this is the mass of solution. We will divide this by density, which is 1.2 gram per ml into 1000. Now we can solve this equation and we will get the molarity. So thank you very much. In the next video we will discuss and we will solve more question on molarity.